Dear learners, today I will be speaking about landslides MEV002. I am Professor Baskar from Guru Jambheshwar University of Science and Technology, Hisar. After listening to this lecture, you should be able to describe landslides, understand the different type of mass movements, analyze the cause and effects of landslides, and understand the landslide mitigation measures. What is landslide? It is downward movement of slope material, rock forming materials like rock, soil, artificial fill, or a combination of these which can result in landslide. And how they can fall? These materials can move by falling, toppling, sliding, spreading, or flowing. Landslides or mass wasting is the downslope movement of regolith due to gravity without the help of geological agents such as water, ice or wind. It is important, learners, to note that this movement is due to gravity alone. There are contributory factors which can be soil saturation due to rainfall or seepage or even human activity like vegetation removal, construction of roads or buildings, or in some cases even natural hazards like earthquakes and volcanoes can cause these landslides. Now, because landslides are simply more than slides and can also occur under the sea, it is better to term them as mass movements. This is a broader term and appreciated than using landslides. Mass wasting is a part of a continuum of the erosional process between weathering and stream transport. Now, mass wasting causes regolith to move downslope, where sooner or later the loose particles will be picked up by another geological agent and eventually move to a site of deposition. So, there is in landslide or mass wasting, there is the gravity which plays the role, and once other agents play, they are erosion, transportation, depositional features. In order for a regolith to move in mass wasting process, it must be on a slope, since gravity will only cause motion if the material is on a slope. That is why these kind of movements require the angle of the slope for them to slide or move down. Now, what are the factors causing landslides? There can be certain natural factors, or there can be certain factors caused by humans. Now, what are the natural factors? If there is absence of vegetative structure, vertical vegetative structure, that will loosen the soil and cause landslide. Similarly, pressure of groundwater can destabilize the slope, or erosion of a top of a slope by rivers or ocean waves can cause landslide. Sometimes weakening of a slope can occur when there is saturation by snow melt, glacier melting or heavy rains. Earthquakes add loads to barely stable slopes. Now, there are also human causes which cause the landslide. For example, if there is some vibration from machinery or traffic, this can cause the land to slide if it is already unstable. If there is a blasting or mining activity which is occurring in nearby area, which is having a slope material on a slope, this can be destabilized. Earthwork which alters the shape of the slope, and in shallow soils, if you remove the deep rooted vegetation, again this can cause landslide. Construction, agriculture, forestry activities which change the amount of water which infiltrate into soil can also cause landslides. Now, what is the failure of slope? Slope failure can be defined as the downward movement of a large amount of material and is classified on how it moves and the type of material. That means the manner of movement and the kind of material involved. They can occur suddenly in one moment, or it may take a long period for it to occur. Slope failures can damage highways, homes and other property. Slope failures can be due to natural events like earthquakes, heavy rainfall from thunderstorms, volcanic eruptions, floodings, or even freeze and thaw of soil moisture can cause the landslides. Now, what are the factors leading to slope failures? Normally, mountainous regions, hilly regions and coastlines have the largest report of slope failures. Why? Because they are inclined, they are in a slope, and tectonically active regions are prone to slope failures which are triggered by earthquake or volcanic activity. In fact, the tremors can shake an already unstable slope. Sinkholes are another common geological feature in karst landscape. For example, if there is a limestone rock and carbon dioxide reacts with it, it can cause the caves, and if these caves collapse, they can fall the subsidence and slope failure features. Streams eroding their bank, you can see the figure, or surf action along the coast can undercut the slope. Since the bottom is cut, the top is unstable and it can cause the slope failure. Now, slope failure can occur in any season, but there is more probability in certain seasons. For example, if there is rain, snow, freezing or thawing of soil water. What you can see is the figure here, modified slope and original slope, and if it becomes steeper, then there will be slope failure. Slope failure can be triggered everywhere and by weather conditions, geological events, human modification of landscape, or most commonly some of the interaction of the above. Now, there are different kind of mass movements. If you see this table, they have classified the slope movements based on the size of the particles and based on the type of movement which is there. Rock fall, for example, if it is a fall, it can be rock fall, debris fall or earth fall. When you call rock fall, it is the core, very coarse. Debris is coarse particles, and predominantly fine are the earth fall. Rock topple, debris slide, earth slide. Similarly, you can have translational movement, rock slide, debris slide, earth slide. You can also have flows. Flows means water is mixing, rock flow, debris flow, earth flow. In some cases, there can be complex movement where there are one or more type of movements which are joined together, and there can be lateral spreads to rock spread, debris spread and earth spread. The only difference is if it is debris or earth spread, it is the size of the particles which is involved, and the nature of fall is also taken into account. Now, mass movement down the slope fall into three broad categories. Fall means they fall through the air and land at the base of a slope. Slide means they move along a flat or curved underlying surface. Flow means it flows. It occurs as a plastic or liquid movements from water saturation. The speed of these mass movements can vary from very slow movements to extremely fast, moving well over 100 miles per hour. If you see this diagram which is drawn, the rock fall, these particles fall through the air, and the fall of the rock particles through the air from a cliff is called rock fall. Earthquakes can trigger this rock fall. Frost wedging is another common cause which can cause the rock fall. Unlike rock fall, flows are masses movements in which material acts as a liquid or fluid and occurs in a wide variety of speeds. And the bottom where the particles, rocks accumulate is called talus. Now, you can see rock and debris slide. Here sliding movement is taking place. Slides occur along flat or curved underground surfaces. Rock slides occur along a flat surface, usually when the layers of the underlying rock are tilted at an angle and are especially hazardous along road cuts. You can see the diagram that the tilting is important. It is occurring along the bedding or the joint planes. Then there is a creep and slump. This is the very slow downslope movement of soil and regolith, and this occurs on slope when frost lifts the soil, then places it further downslope. Gravity also acts to pull the upper layers of soil and regolith downslope, causing fences, telephone poles to be tilted. And slumps occur when the material slides along the curved surface. Slumping is caused by the erosion at the base of a slope by, for example, by water action. Slumping can also occur when excessive water is added to a slope. The steep slope at the head of the slump is called a scarp. Now, there is another term which is called solifluction. Solifluction occurs when the upper layers of the soil become saturated and move downslope, common in very cold climates where permafrost forms. During summer, the upper layers of the permafrost melts, saturating the ground, causing solifluction lobes. Mud flows are again flows, mixtures of water and soil up to 30% water, and occur where water has become saturated with soil to the point that soil has become liquid. They occur after forest fires have denuded the vegetation and occur around construction sites. Then there is debris flow, which is the coarse particles. A debris flow is a very rapid downslope movement of rock debris and regolith. They often start as slumps or slides but become debris flow as the material mixes with more air and more water. Debris flow gain their rapid speed because they actually ride on a cushion of air as they flow downslope, as confirmed by experimental observation. A debris avalanche is an extremely rapid downward movement of rock debris, regolith and soil, more common in areas with steep slope. The term avalanche is generally applied to any type of fast moving downward material, but it is associated with steeper slopes than debris flows. Now, what are the factors that affect mass movement? There are two factors which combine to cause the mass movement. One is the driving force that promotes the movement, other is the opposite one, the resisting force that deter the movement. Whenever driving force are greater than the resisting force, then the material on the slope will break loose and move down the slope. That means the condition is driving force should be greater than the resisting force. Now, what are the driving forces and what are the resisting forces? Obviously, you must be clear by now, gravity is a driving force. Steeper the slope, greater is the tendency of the material to move down slope. Gravity is the primary driving force. It is influenced by human activities such as excavation. Again, rock structure is an important driving force. Rock structure can, because rocks are far from being completely solid and have pore spaces which can allow water or air to infiltrate, and they can break along the natural fractures or joints in rock caused by stress, and the contact between the different rock types are the planes of weakness. So, rock structure is also a driving force. Water is also a driving force, but in certain cases its role is complex. Water, what it does as a driving force, it increases the weight of the slope material by filling previously empty pores and fractures and promotes mass movement. Water decreases the strength of the rock or sediment by reducing cohesion among the particles. Water can also infiltrate pore space, then freeze, that is freeze and thaw movement, frost heaving, break the rocks apart. Water can create shrink swell clays, which are common hazard in the construction of building foundations. What are the resisting force? Water can also act as a resisting force in certain cases. In the sediments pore spaces that are not completely filled, a thin film of water actually makes the particles stick together due to cohesion. Cohesion is the ability of the particles to attract and hold each other together. So, you are seeing water, if it is in excess amounts, it becomes a driving force. If it is in very less amount, it will be a resisting force. Now, what are the factors that affect the stability of particles on a slope? The angle of repose is the maximum angle on the slope to which a sediment can be piled. There are some factors which determine this. One is the particle size. Larger the particle size, they maintain a steeper slope than smaller particle size. Particle shape, particles with angular edges can have steeper slope than one with rounded edges. Particle sorting, poorly sorted particles have all sizes represented. They can have steeper slope because the smaller particles can fill the space between the larger particles. Particle moisture, particles with some water can have steeper slope than particles with no or too much water. Particle packing will also affect the stability of the slope, and packing describes the arrangement of particles in the sediments. Now, can the mass movements be predicted? Slopes are considered unstable only if they are composed of rocks that can be easily dissolved, such as limestone. Slopes are also considered unstable if the layers of the rocks are tilted rather than horizontal. Slopes that are constantly waterlogged or highly saturated are considered unstable. Some clues to look for are springs along the slope, areas of soggy ground, and standing pool of water. Now, what are the clues that indicate an old slump? Hummocky ground at the base of a slope. Sometimes you find trees that are different in age, young occur in the slump itself, and older tree grows outside the slump. Sometimes the fence lines may be displaced. Then there is increased rate of soil creep may be indicated by downslope tilting of trees and vegetation growing on the slope. This suggests a rapid creep rate which is occurring. Now, there is relationship between landslide and water. You are clear by now. Slope saturation by water is the primary cause of landslide. This will occur in the form of intense rainfall, snow melt, changes in groundwater level, water level changes along coastline, earth dams, and the banks of lakes, reservoirs, canals, or rivers. That means water and landslides are strongly interlinked. Landsliding and flooding are closely related because both are related to precipitation, runoff, and the saturation of groundwater. Landslides can cause overtopping of the reservoirs or can have cause the reduced capacity of the reservoir to store water. Now, landslides and seismic activity are also interrelated. The occurrence of earthquake in steep landslide prone areas greatly increases the likelihood that landslides will occur due to ground shaking. Widespread rock falls are also caused by loosening of rocks as a result of ground shaking. Now, landslides and volcanic activity are also interrelated. Volcanic lava, which being hot, can melt snow at a rapid rate, causing a deluge of rock, soil, ash, and water that accelerates rapidly on the steep slope of volcanoes, devastating anything in its path. These volcanic debris flows, they are also known as layers, reach great distances and can damage structures in flat areas surrounding the volcanoes. Landslide can cause effect on buildings. For example, the buildings can be damaged because of this. Now, landslides and plant life are interrelated. This is a new subject area called landslide ecology. Landslide can affect plant life and ecology, as any kind of plant life in the slides will get washed down with the slide. The steeper the slope, the more likely the slide will occur. What are the precursor events before the occurrence of landslides? What are the indicators? Springs or saturated grounds that are normally wet are not so. Water breaks through ground surface in new locations. New cracks or bulges in the ground can be a prediction to landslide. If the concrete foundations crack or move, a landslide perhaps can occur. When the poles, trees, or fences begin to lean, a slide may be on its way. Doors or windows begin to stick together or jam. New cracks begin to appear in plaster, tile, brick, or foundations. Outside walls, walkways, or stair begin to pull away from the building. Cracks can begin to widen on the ground or paved areas such as street. An underground utility line begins to break. These are the signals that something is occurring for the landslide. Now, how can we prevent and mitigate the mass movements? Vulnerability to landslide hazard is a function of location, type of human activity, use, and frequency of landslide event. The effects of landslide on people and structure can be reduced by total avoidance of landslide hazard areas or restricting, prohibiting, or imposing conditions on hazard zone activities. Landslide effect can be reduced through proper land use planning, policies, and regulations by the local government. Now, the hazard from the slides can be reduced by avoiding construction on steep slopes and existing landslide, or we can stabilize the slopes. Stability increases when groundwater is prevented from rising in the landslide mass by covering the landslide with an impermeable membrane, directing the surface water away from the landslide, draining the groundwater away from the landslide, or minimizing surface irrigation. Now, some mitigation measures are, we know the causes, so we have to remove the causes of this. Primarily, we should avoid building in an area which is prone to mass movement, but this is not always possible because of increasing populations. Slopes should be drained and could be achieved by intercepted drains that can be built at the top of the slope to channel water away. Wells that can be driven into the slope to allow water to be pumped away. Essentially, we are removing the water from the area. Then perforated pipes can be driven into slope to capture water and drain it away by gravity. Again, we can see water is removed. Some mitigation measures are summarized. Slope reduction. The steepness of the slope can be manually decreased by construction. Concrete coating can be applied to the slope to seal the slope and prevent water from infiltrating, also to prevent frost wedging. Retaining walls can be constructed at the base of slope. Rock bolts can be drilled into tilting rock layers to prevent them from slipping. Structures can be built in areas prone to mass movement. A more popular one is the use of cable net and wire fences to catch rocks and debris from tumbling down into highways and neighborhoods. Now, intercept ditches can be built to catch any falling debris and prevent it from rolling onto road. Rock sheds and tunnels can be built, and avalanche sheds can be built in areas prone to snow avalanches. Now, summary of this, after listening, you must have understood the different type of landslides, what are the flows, what are the slides, and what are the rock falls, the different types, then what are the driving forces and resisting forces, and analyze the cause and effects of landslide. And if you have understood the cause and effect of landslide, you will learn to mitigate the landslide measures which I have explained in the previous slides. Thank you very much for the patient listening.